Hello everyone. Today we'll be talking about parallel lines and the transversal. So we will be identifying different types of angle pairs created when a transversal intersect parallel lines. So we'll be looking at different types of angles and the relationship to lines. We'll be using the properties created by those angles and see how we can solve problems by using these properties. But before we go ahead and do that, we need to revisit some topics. This include vertical angles, supplementary angles, and linear pairs. So let's first review vertical angles. The way we can remember vertical angles is by imagining a cross, or the multiplication sign. So let's define vertical angles. Vertical angles are angles opposite to each other made by intersecting lines. So we know that they are going to be opposite to each other. So I can see that 1 and 3 are opposite to each other, 2 and 4 are opposite to each other. So we can say that angles 1 and 3 are vertical angles, and angles 2 and 4 are vertical angles. And what we know about vertical angles is that they are equal. So the angle made here is going to be equal to the angle made here. And the same with 2 and 4. Okay, next let's review linear pair. We can see from the word linear that the word line is there. So we can think of it like making a line. So as you can see here, angle 1 and angle 2 are making this line here. So the way we define linear pair are those like a pair of angles that are next to each other, right? Adjacent is the term, that make a line. So they have to be next to each other. They're sharing some kind of line here, and they're sharing another line here. And that's the line they're making. Okay, so let's look at those two examples and see which one are linear pairs and which are not. So the first one, we see that angle 1 and angle 2, they're next to each other, they're adjacent. Okay, so we satisfy the first condition. Are they making a line? Yes, they are sharing this line here, right? So yes, they are making a line right here. So those are going to be linear pairs. What about example 2? So we can see that they are not next to each other. No, they're not sharing any lines. They're separated, right? This angle is separate from this angle here. So therefore, they don't even satisfy the first condition, so they cannot be linear pairs. Okay, what about supplementary angles? So I can say that these two are supplementary angles, and if you notice, if we add 120 plus 60 degrees, we get 180. So it's exactly that. Supplementary angles are two angles that add up to 180. So those are supplementary angles. Okay, so let's go ahead and delve into the new lesson, and the first thing we're going to talk about is the transversal. So let's define it. The transversal is a line that intersects with two or more lines. So we have that the transversal is a line, that's how it looks like, and it has to intersect with two or more lines. So can you guess in that picture which line is a transversal? Is it the blue, the pink, or the green? So if you notice, the blue line is intersecting the pink, and the green is intersecting two other lines. While the green and the pink are only intersecting the blue line, right? So the blue line would be our transversal because it's a line, right? And it's intersecting two other lines, the pink and the green. Now, when we have that shape, we're going to get some interesting angles here, and that's what we'll be talking about today. What is it about these angles and how we call them? First thing we're going to look at are interior and exterior angles. So from the word interior and exterior, you would think something is inside and something is outside, right? So, but inside of what and outside of what? We're going to say that interior angles are located in between the two lines. And the two lines we're talking about here are the pink and the green. So let's go ahead and label our interior angles. So it's going to be 3, 4, 5, and 6. So these are our interior angles because they are in between the lines L and M. Okay, what about the exterior angles? So they're going to be outside, right? Again, they're going to be outside, located in the outer part of the lines. So outside of the lines L and M. So they're going to be angles 1, 2, 7, and 8. So the exterior angles are those indicated by the blue, and the interior angles are those indicated by the yellow. Okay, with this one here, we're going to, instead of using the animation, we're going to play with it ourselves a little bit. So we have something called, we're going to talk about alternate interior angles. So we already talked about the word interior, right? We know that interior are going to be the ones inside the two lines, right? So let's circle those ones. So 3, 4, 5, and 6 are going to be our interior angles. What about the word alternate? We can kind of think of it as zigzagging, they're changing in a certain way, right? So the way we're going to think about alternate is they're going to be diagonally opposite. How does that would look like? Be something like that. Diagonally opposite from each other, right? As you can see, they are at a diagonal angle and they're opposite from each other. But remember that we said that they have to be interior, right? So the thing that we see overlapping here, or the angles we see overlapping between the interior and the alternate, are going to be our angles 3, right? And angle and angle 5, right? So these angles 3 and 5 are going to be our alternate interior angles. Let's do the same thing again and see what happens if we look at the opposite this way. So again, it's going to be our interior angles. Let's remove this, right? But this time, instead of looking this way, I'm going to look at this way, okay? So again, I have the interior circle, right? And the alternate, which means diagonally opposite, and the ones overlapping is angle 6 and angle 4, right? Okay, so let's go ahead and write down the definition. So alternate interior angles are going to be interior angles. That's the first condition, right? Look, we're only looking at the angles between the two lines. And they're going to be located on diagonally opposite sides of the transversal. Diagonally opposite. As you can see, we said that 3 and 5 are going to be alternate interior angles, and 4 and 6 are going to be alternate interior angles. Another way we can think of this is they are not linear pairs. They cannot be next to each other. We cannot say that 5 and 6 are alternate interior angles. Okay, so that's one way to remember it as well. But as if you're good with the first two condition, you can find alternate interior angles. Okay, so what about exterior? You might have already guessed, right? Again, now we have exterior, right? let's do our exterior angles. So those are going to be our exterior angles, right? Outside of the lines. And as we said, alternate means diagonally opposite, right? So let's do that. They're diagonally opposite. Not going so well, but here we are, right? So which ones are overlapping? Can you make a guess? So we have the two red circles here, right? And the black oval shape. And we have the overlapping ones are angle 2 and angle 8, right? So those are going to be alternate exterior angles. And again, we can do the same thing, but look at the other way, right? Diagonally opposite this way. And we're gonna see that angles 1 doesn't appear very well here. Okay, angles 1 and 7 are going to be alternate exterior angles. So let's go ahead and write the definition. So alternate exterior angles, from the name, has to be exterior angles, right? So they're outside of the two lines. And as we mentioned, they have to be located on diagonally opposite sides of the transversal. As you can see here, opposite sides from the transversal, the blue line. Again, we can think of it that they cannot be touching, right? They are not a linear pair. Okay, the next angles we're gonna talk about are called same side. Again, with those ones we have same side interior and same side exterior. So let's go ahead and define the interior ones first. Same side interior angles. Okay, we know they're going to be interior, right? So they have to be in between the two lines. Now, same side means they are located on the same side of the transversal, the same side of the blue line. So either on the right or on the left. So if I look on the right, I would have the overlapping angles 3, 6. 3 and 6 would be our same side interior angles, right? And if I look at the left side and see the overlapping angles, I would have 4 and 5 as same side interior angles. So those would be our same side interior angles. They're interior and located on the same side of the transversal, either right or left. Now let's look at same side exterior angles. So they are exterior. So I have to find my exterior angles first. They are the ones outside of the two lines. Next, they are located on the same side of the transverse, either right or left. Let's do the same thing again and see the overlapping. So I would have angles 2 and 7 as same side exterior angles. And if I do it on the left, I would have angles 1 and 8 as same side exterior angles. Okay. Now we're going to talk about something really interesting here called corresponding angles. So far we have been seeing that there's a relation between interior and exterior, right? And that we talked about alternate, we talked about same side angles and their relation, whether they're interior or exterior. What about corresponding angles? Is it the same way? Well, it's slightly different. So corresponding angles, on the other hand, would have one interior angle and one exterior angle. So that's a bit different from what we have been looking at, right? So since they have one interior and one exterior, I'm going to highlight one exterior angles here, right? And some exterior angles, right? So these are exterior angles, right? We agree 1 and 2 are exterior, outside of the two lines. 5 and 6 are interior, they're in between the two lines. Okay? And now they're going to be on the same side of the transversal, so either left or right. So we'll have this. Let's try the right first. So again, we'll look at the overlapping. We'll see that 2 and 6 are the overlapping between the red and the black shape, right? So 2 and 6 are going to be corresponding angles. We can do the same thing on the left side, and we'd have 1 and 5 are corresponding angles. But then you could ask me, why did we choose the red shapes to be over there, right? I could have it here, but if I have it here, then I'll have to use the other pairs. Remember, because it has to be 1 interior, 1 exterior, right? And again, I can use the same side idea, right? So I'd have angles 3 and 7 are corresponding angles. Angles 4 and 8 are corresponding angles. So that was a bit maybe overwhelming. So let's try to write it again and with the definitions. So what are corresponding angles? Angle pairs that are on the same side of the transversal and same location with respect to the other lines. Okay? Note, one is exterior and one is interior. Only corresponding angles do that. Okay? So let's look at the definition again and the picture and see the connection. So angle pairs that are on the same side of the transversal, right? Okay, so if I'm looking at the right side here, and same location with respect to the lines, what does that mean? So if I'm looking at angle 2, I can say that angle 2 is on top of is on top of the line L, right? Or the pink line. Then I'm going to look at what angle is on the right side that is on top of another line, right? And that would be our angle 6, because it's on top of the green line. So angles 2 and angle 2 and 6 would be corresponding angles. If we do the same thing again with angle 3, then angle 3 is below the line, the pink line. Then I'm going to look at angle below the green line, which is angle 7. So they're on the same side of the transversal and in same location with respect to the lines. If same location with respect to the lines is a bit hard for you, remember that one has to be interior, right? And one has to be exterior. So this is our interior, then the other one has to be exterior and the same side with respect to the transverse. Okay. Now, so we were looking at a transversal, right? And other random lines going through the transversal, right? Getting intersecting. What happens if these two lines here become parallel? Okay, so I would have a transversal, and these two lines that are intersected by the transversal have now become parallel. What happens then? Well, these angles we talked about would have a certain properties. So what happens if the lines intersected by transversal are parallel? We can say that the vertical angles, the corresponding angles, the alternate interior angles and alternate exterior angles would become congruent. What does that mean? That they are equal in value. What about the other things we talked about? Like linear pairs, same side interior angles, and same side exterior angles? Those become supplementary. And we said supplementary means they add up to 180. So when you add them together, their values should add up to 180. So that only works when the lines intersected by transversal are parallel. So let's look at some observations that can help us remember some properties of those angles or how to identify them. So, and we're going to look at those angles in terms of the transversal or either their exterior or interior. So if I'm looking at alternate angles or trying to identify alternate angles, I'm looking for them to be diagonally opposite with respect to the transversal. And they have to be both interior or both exterior, depending on the name, right? So both alternate interior angles or alternate exterior angles. Now let's look at same side angles. Same side angles have to be on the same side of the transversal, right? That's why we have the name same side. Again, they're either both interior or both exterior. Now, with corresponding angles, they are the same side with respect to the transversal, but one is interior and one is exterior. So you can use that kind of table to help you identify the angles. And again, you can also use the idea of overlapping, draw your circles and do the oval shape if you're ever confused, and find the overlapping angles with using the definitions. So that will be it for this lesson. Thank you. Thank you, everyone.